So here we have a mass on a string of unknown length that oscillates as a pendulum with a period of 4.0 seconds. And they ask us what the period is if the mass is doubled, the string length is doubled, if the string length is halved, the amplitude is halved. So this is one of those multi-step problems, but it's not too bad once you go through it again. So we know that the equation for the period of a pendulum is equal to 2 pi times square root of L over G. This is on your equation sheet. So the answer is part A. If the mass is doubled, we can see that the mass doesn't appear anywhere in this expression. So therefore, the period shouldn't be affected if the mass is doubled. Therefore, there is no effect. The period is 4 seconds. There we go. For part B, what happens if the string length is doubled? Well, we know that if we plug this in, this new thing over here is equal to 2 pi times 2L over G, and that's equal to square root of 2 times 2 pi L over G. So it's just square root of 2 times the TP old really, but that's kind of a lot, so maybe I won't write it. So this should increase it by a factor of square root of 2, so all we have to do is multiply that 4 times root 2, and we get the new period is 4 times square root 2 seconds, or if we account for sig figs, 5.66 seconds. For part C, if the string length is halved, well, then again, it's just if we plug this in to here, and if we do the math, we can see that this is equal to 2 pi square root L over G. So therefore, this is just 1 over square root 2 of the original period. So therefore, we can just multiply 4 divided by square root 2. So this is equal to 4 divided by square root 2 seconds, which is just 2.83 seconds. If we account for sig figs, because the problem gave us some sig figs. For part D, if the amplitude is halved, well, we can see that amplitude doesn't appear anywhere in this expression either, right? Because it's just L, which is the length of the pendulum, and G, which is gravitational acceleration. So again, the answer is no effect, or 4 seconds. And that should be it. And that's all there is to it.